Okay, today we're going over 8.5 exponential and logarithmic equations. So we're going to break this lesson up into two parts here. So we're first going to just remind ourselves how we can break this up as writing it from logarithmic form to exponential form. So let's take a look at if I have something where we have y is equal to log base b of x, then we know that this is in logarithmic form, and the equivalent to this for exponential form would be base b, so b to the y is equal to x, and these are equivalent forms. So if you look at any of these, if we're not sure of what this is equal to, I can say this is equal to x, and then I can change it to exponential form. So for this one here, I'll have my base is a 2, the exponent is an x, and it's equal to 2, which is the same as writing 2x is equal to 2 to the first. And once you have the same base, you set the exponents equal, so therefore x is equal to 1. So all of these are going to be equal to 1. If these numbers are the same, then it's always equal to 1. Okay, so what we're going to be doing today is we're going to be now using exponential and logarithmic form, and we're going to be solving equations. So you will need a calculator for this. So let's start here with 3 to the x is equal to 4. So before we did any type of exponential or logarithmic equations, you would look at this and it would look rather difficult to find out 3 to what power would be equal to 4. So now what we're going to do is we're going to take the common logarithm of both sides, and we know that the common log is a log base 10. That's the common log. So we're going to take the common log of both sides, and we know that when I take the common log, I don't need to put a base of 10. I don't need to write that in. It's just known that that is a base of 10. So I'll take the log of both sides here, and from the 8.4 video and notes, we should have remembered that if I have a power, by the power property, I'm going to bring that in front, and therefore I will get x times log of 3 is equal to log of 4. And now I'm solving for x, so I'm just going to divide both sides by log of 3. And then this is what you will put in your calculator. So x is equal to, putting in your calculator, log of 4 divided by log of 3. And I'm just going to go ahead and put that in my calculator right now. Log of 4 divided by log of 3. And that is equal to about, we're going to round it to the nearest 10,000th. So 1.2619. And you can actually check this by plugging this back in. 3 to this power will give you 4. Okay, trying another one here. We're going to do a similar thing where we're going to take both sides to the common log. We're going to take the common log of both sides. So log of 7 to the 3x is equal to log of 20. So again, using our power property, we'll bring this in front, and we'll get a 3x times log of 7 is equal to log of 20. And we are solving for x here, so we will divide both sides by 3 times log of 7. And if you wanted to, you can actually evaluate what this would be, because we know that if there's a number in front, we can make that be the exponent. So in my calculator, I can either write it as log of 20, it will open your parentheses and close it, divided by, put parentheses here, so this is how you should write it in your calculator. Put parentheses here, 3, and then we have times log It will open the parentheses for you here, 7, close your parentheses, and close your parentheses again for the entire denominator. You can put it in your calculator like that, or what you can do is you can put it in your calculator where you're actually having 3 as the exponent, which would be 7 cubed is 343, and then you can put it in your calculator like that. Either one will work. So if we do either one, log of 20 divided by log of 343, then we'll get x to be about 0.5132. And also, again, you can plug that back in and check your answer to make sure you get 20. Okay, moving on here, we're going to learn the change of base formula. So what this is showing you is you can change the base of the log to be whatever you need it to be. So, for example, if I have, let's say, log base 3 of 6, this is equal to, if I change it to a common log, this would be log of 6 divided by log of 3. And that would be giving it a common log where our base is a 10. And common logs you can put in your calculator along with natural logs. So for this one, log base 3 of 15, we want to evaluate that first, and then we want to convert it to have a base of 2. So we can evaluate this by using the change of base formula, which says log base 3 of 15 is equal to log of 15 divided by log of 3. So we'll just put that in our calculator. So this is going to be about log of 15 divided by log of 3 is about 2.4650. Okay, so now what we're going to do is we're going to change it to have a base of 2. So we know that I have log base 3 of 15, and I want to make that log, instead of base 3 now, I want it to be a base 2 of, we need to find the value of x. That will make this true. So we just found that log base 3 of 15 is log base 15 over log of 3, which is equivalent to this. So I'm just going to rewrite that as 2.4650 is equal to, we can use change of base formula here and write this as log of x over log of 2. You could do that. And then multiply both sides by log of 2. Or you can just convert it straight to exponential form from there. So we'll multiply by log of 2. Multiply by log of 2. And then these will cancel. So hopefully we didn't clear this out of your calculator. Don't clear it out of your calculator until you're done with the problem. So this will be times log of 2. And that will give us 0.7420. And that is equal to log of x from here. So we did log of 2 times 2.4650. We got 0.7420, and that's equal to log of x. So now we're going to change it to exponential form, and we know that if there's no base written in, it's a base of 10. So I have 10 to this power, which is 0.7420, is equal to x. So then don't clear it out of your calculator and just go 10 to that power. And we should come up with an answer of x is about 5.2, x is about 5.5212. And again, you can plug this back in to check that it's the correct answer. The other way you could have done this is from here, if I just kept this as log base 2 of x, and set it equal to 2.4650, I could have done 2 to that power and made sure that that was correct as well, and you'll get the same answer for that. Okay, so moving on. Let's do another one here, evaluating log base 5 of 400 and converting it to a base of 8. So we'll first convert this because we know that's log of 400 over log of 5. So we'll first put that in our calculator as log of 400 divided by log of 5. And any scientific calculator will have logarithms on there. So this is about 3.7227. Okay, so we want this now to be a base of 8. So we can say, all right, I'm going to make this log base 5 of 400, which is log of 400, over log of 5. We want that to be equal to log base 8, and we'll find x. So we just said that we're going to have log of 400 over log of 5. We just found what that was. Let's see here. Let's just move this down a little bit so we have a little bit more room. Okay, so back to this problem here. We're going to change this now to be, we just found what it is, so this is a 3.7227, but don't clear that out of your calculator, and that's equal to log base 8 of x. So in the previous problem, what we did was we multiplied both sides by log of 2. We used change of base formula, multiplied both sides by log of 2, and then we converted it to have a base of 10. So for this one, what you can do is you can just change it right away from here. 8 to the 3.7227 is equal to x. So I'm going to go 8 to that power. And if you don't clear it out of your calculator, it'll make it more accurate. So this is about 2301.1171. And that's how we use the change of base formula and get the answer to change whatever base we need it to be. Okay, so we're gonna end with this one for this video. And another way we can solve these is by looking at whatever the base is here and taking the log of that base for both sides. So since the base is a 2 here, because we look at the base of whatever has the exponent x, we're going to use that base. So I'm going to use log base 2 of 2 to the 3x is equal to log base 2 of 172. Using our power property again, we're going to bring that in front. 3x times log base 2 of 2 is equal to, I can use a change of base formula and make it log of 172 over log of 2, which simply just means that they both have a common base, which is a base of 10 now. So previously in the earlier slides, we went over that log base 2 of 2 is equal to 1. So 3x times 1 will just be a 3x. And then we can find what this is here. So we'll have log of 172 divided by log of 2. And that will give us about 7.4263. And then we'll divide both sides by 3. And x will be about, dividing by 3, we'll get 2.4754. And we can plug that in to make sure that we are correct. So you can actually do times 3, which is 7.42, and then 2 to that power. 2 to that power will give you 172. And And that will be it for today. Thanks for listening.